This is the first video for Exam 2 review for fall of 2018. I'm going to be going over the questions from the review, starting with number 1. So, the first question asks a lot of questions about this function, negative sine of 3 theta minus 3 pi over 2 plus 2. The information that we need to pull out of here involves our function. So we know that a equals negative 7, meaning there's going to be a reflection across the x-axis. We know that b is equal to 3. We know that c is equal to positive 3 pi over 2. And we know that d is equal to positive 2, which tells us there's going to be a shift up. C tells us there's going to be a shift to the right. I'm going to go ahead and graph the function, and then we'll see what information we can pull out of here. So to do this, we're going to make a chart. I went ahead and set up the chart that we're going to use for this. And remember, because this is a sine function, we want to choose quadrantial angles. So we can start by choosing negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Our next step is to determine from here what 3 theta will be. In order to do this, we need to add 3 pi over 2. I'm going to make some of these so that we already have a pi over 2 denominator, and I do this by multiplying by a value of 1 that's 2 over 2. Now we can go ahead and add. I went ahead and added and filled in the values. Our next step backwards is that we need to determine what our value of theta is, if we know that 3 theta is this column here. In order to do that, we look at this coefficient, which is 3, so we need to multiply everything by 1/3. It's also okay if you say I need to divide by 3. I'll go ahead and work this out, noting that some of these cancel. So for example, this becomes pi over 2. From here, there's some information that we can gather about our function. We actually know, looking right here, that there is a shift. Like we mentioned earlier, that shift is actually going to be to the right, and it is pi over 2 is our shift. Now, we can actually also gather from here what the period of our function is, and it's this distance here. So our period should be 7 pi over 6 minus pi over 2, which is 3 pi over 6. We get 4 pi over 6, which becomes 2 pi over 3, which is the period of our function. In order to complete this for graphing, we need to fill in the remainder of our table here. I'll go ahead and do that for us. So remember, we picked values, so this would be easy. The sine of negative pi over 2, which is what this whole thing equals here, the sine of negative pi over 2 is we get negative 1, 0, 1, 0, negative 1, 0. Then we multiply by negative 7, so we get positive 7, 0, negative 7, 0, positive 7, 0. Now we do this add 2 here, so we get 9, 2, negative 5, 2, 9, and 2. I'm going to zoom out so that this does become a little smaller, but it allows us to see what we're trying to graph here. So we can plot these points as needed. So we have a point at pi over 3, looking here, and our output y value is 9. So I can find pi over 3 and go up to 9. I then have a point at pi over 2. My value is 2. And at 2 pi over 3, my value is negative 5. From here, I can go ahead and fill out the chart. And now I can sketch in my curve. I've also answered most of the questions that were asked up here. The amplitude is the absolute value of -7, which is 7. The period is 2 pi over b, which is 2 pi over 3. But again, we found all of that down here. So remember that by doing your chart for graphing, you found this information already. Any shifts that the graph has, so I'll fill these out here. Remember, we have a reflection across the x-axis. We have a shift up 2. And we have a shift to the right by a value of c over b, which is pi over 2. But again, we got that information from here as well without remembering the c over b bit. We have now graphed our function over at least 2 periods, and we're done with this one. Now we're going to talk about number 2 from the review, which asks that we graph a cosine function. Again, looking at all the definitions, we have an a value of 3 and a b value of 4. Notice that c is 0 and d is 0, which means we can expect that there will be no horizontal or vertical shifts of the graph. So this is what our chart looks like to graph this. Remember, we're going to start here with the 4 theta column, and we want to pick the values of the quadrantial angles. Since this is a cosine function, we don't need to worry about picking pi over 4 like we would for cotangent or tangent. So we'll start with negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this will allow us to see how long one period of the function is for 4 theta as we work backwards. Now, in order to find the value of theta, we multiply by 1/4. And now we can work in the forwards direction, finding our function values. Cosine, remember, is the x value where the circle, where the angle intersects the unit circle. So we have a 0, 1, 0, -1, 0, 1. And now we multiply 3 to find our function value, 0, 3, 0, -3, 0, 3. So from this, we can see that the period of the function is going to be pi over 2, because that's the distance. We can also see that because 0 continues to be at 0, there's no phase shift, just like we expected. Now let's plot some points and see what this looks like on the graph. We can then follow the pattern to find what the remaining points on the graph look like. And then we can sketch it in. And that is what the function looks like. Let's go back now and answer some of the questions that were asked. The amplitude of the function is the absolute value of that a value. Remember, only cosine and sine functions have an amplitude. So this will have an amplitude of 3. We know that the period is 2 pi divided by b, which in this case is 2 pi over 4, which will be pi over 2. Again, we found that down here when we manipulated backwards from our argument of 4 theta to find theta. And then we showed how we found some points and graphed it. For number 3 on the review, we are asked to graph at least 2 consecutive periods of the function 3 secant 4 theta. I want to just remind you that this is 3 times the reciprocal of cosine 4 theta, and cosine 4 theta is the graph that we just drew. So I'm going to sketch that in for us using the information from number 2. I have now sketched in the graph of y equals 3 cosine 4 theta. So remember, we're now finding the graph of 3 secant 4 theta. The first question asks to find the equations of 3 consecutive vertical asymptotes. These are going to occur everywhere that the cosine function intersects the x-axis. So I'm going to sketch some of these in so that we can see them. Now you can see that I've sketched in, so these red vertical lines are the asymptotes. I'm asked to find the equations of 3 consecutive ones. So I'll start here looking back at my work from number 2, and we will have an equation of theta equals negative pi over 8. We'll have an equation of, then the next one to the right is pi over 8, then 3 pi over 8 is the one next to it. Again, these are equations, so it should be theta equals this. You could have also continued going and found any 3 that are in a row. So I did these 3. You could have done those 3 or those 3, however you see this. Now, remember that the cosecant function actually cannot have values between -1 and 1. So 1 and -1 are where it would intersect our cosine graph, but we're multiplying by 3, so they will share these points at the peaks and the valleys. And graphing in our cosecant graph, it will look like this. Making sure that those asymptotes do their job of that's where the function goes to either positive or negative infinity as it approaches those asymptotes. You are asked to find interval notation for the range. And remember, for negative infinity or positive infinity, we use parentheses. So we go from negative infinity to -3, and that traces right in here. Negative infinity to -3. And then we connect this with going from 3 to infinity. And you can see that here we go from 3 up to infinity. For number 4, we are asked to graph a tangent function. Remember that tangent functions have no amplitude. We do have an a value of 3, meaning that my function will be stretched vertically. We have a b value of 4, meaning the period will be changed. And we have a c value of positive pi over 2, meaning that we will have a shift to the right. So the range of h, which is the range of our tangent function, will be from -infinity to infinity. We need to give the equations of some vertical asymptotes, so we'll start off by making our chart to find out what the graph looks like. So in graphing a tangent function, we need to make sure that we include different values to take the tangent of than we do for sine and cosine or cosecant and secant. So we want to use negative pi over 2, and then we want to use negative pi over 4, and then 0, pi over 4, pi over 2, 3 pi over 4, and pi. So just to remind yourself, on the unit circle, everywhere that we have a pi over 4, where there's an odd numerator so that it won't cancel out, remember that we have tangent of theta is 1 or negative 1. That's why we want to make sure we include these. Also remember that the period of the regular old tangent function is pi, which is why we only need to go from 0 to pi in order to cover one full complete period of the tangent function. I'm going to include a couple more points just so we can see what's happening on our graph. I'll include 5 pi over 4 and 3 pi over 2. Now, in order to find from this column to this column, remember, we will add pi over 2, which is also, in case we need a 4 on the bottom, 2 pi over 4 to give us that information. So we should be able to add in order to go over. When we add, we get 0, pi over 4, pi over 2. I'll continue to finish out this column. And remember, I'm just adding pi over 2 in order to go from this column to this column. So now that I've finished completing the 4 theta column, we can talk about how to calculate over for the theta column. And we will do this by either dividing by 4 or multiplying by 1/4. So we should get 0, pi over 16, pi over 8, 3 pi over 16, and I'll finish this out. So this is our theta column. So remember, this is what we will graph along the x-axis. Now we can move forward calculating here. So when we take the tangent of this column, remember, tangent does not exist here, and it doesn't exist here. So the tangent of negative pi over 2 does not exist. We have a vertical asymptote at theta equals negative pi over 2. Negative pi over 4. We have a value of negative 1, 0, 1. Then at pi over 2, we have a value of does not exist. So we have a vertical asymptote at theta equals pi over 4. I said something wrong up here, so I'm going to go back and fix it. This would be at 0, because we should use the value from here, not here. So I made a mistake there. I've gone back to fix it. Now, 3 pi over 4, we're right here. So remember, that's going to give us a value of negative 1, 0, 1. And then 3 pi over 2 does not exist. We have a vertical asymptote at theta equals pi over 2. These would be the 3 values here for consecutive vertical asymptotes that is asked for in the question for part A. So looking at our graph, we should first make sure that we graph in our vertical asymptotes so that we can see where those are. So again, I will sketch those in blue so we can see them. Remember, we had one here. We will have one at pi over 4. We'll have another one. We'll have one at pi over 2. We'll have one at 3 pi over 4 as well. And in fact, going backwards, we would have one at negative pi over 4 and at negative pi over 2. Right. We need to then finish out our chart down here at the bottom. So we would multiply these by negative 3. I'm sorry, positive 3, because that's what this is. It would not be multiplied by negative 3, but this first one is negative 3. And we would get this same pattern again and again. So plotting our points, you can actually see that there are 32 segments in between a pi. So pi over 16 actually is right here, and that would be negative 3, 0, and then we go up to 3. And then the pattern just repeats itself. Negative 3, 0, 3, negative 3, 0. And then we would just sketch it in. I'm going to sketch it in kind of in red, so you can see how these graphs look. And that is the graph of our tangent function for number 4. For number 5 in this video, we are asked to use the graph given to model a cosine function. It's important to note a couple of things. First of all, we are asked to do a cosine function, so we can try to remember and use pieces of the cosine function so we can figure this out. We are also told that a is greater than 0, and that write the phase shift as the smallest possible in either direction. So let's start unpacking this to see what we know. We know that the amplitude, we go up here to 5, we go down here to negative 5. So because they are the same number, we know that the amplitude is 5. So we know the absolute value of a must be 5, but we know that a is greater than 0, so a is actually 5. Now, moving on to finding out the period of the function. We can either look from 2 consecutive valleys straight across. We can look from 2 consecutive mountains straight across, though we are not given the value of this, so that would be harder to do. We can, however, look for, across 3 different zeros, and the reason we don't want to look only from here to here is that notice this one is going down, well this one's going up, so that's not a full period. We would need to look at the distance from here to here. In fact, it's probably easier to use the one that I highlighted in pink. So we know that the distance from negative 2 pi over to 4 pi is actually a distance here of 6 pi. That's our period. So we know that 6 pi must equal 2 pi over b. So using cross multiplication, we understand then that b must be 1/3. Now we need to look for our phase shift. Remember that using the unit circle, we know that we can expect that we will have a, just to put the unit circle out there for us, and we'll draw across here, and we'll draw down here. We know that at 0, our cosine function is going to have a value of 1. So we know that 5 cosine 0 is going to be 5. But in fact, what we know is that we have a value here and a value here. We can see, I hope, that this distance is pi, while this distance is 2 pi. So this one is obviously the smaller distance. So what we know is that 5 cosine pi is equal to 5. So we know that we have a phase shift pi units to the right. So what this means is that C over B must equal pi. We know that B is 1/3, so that means that C must be pi over 3. And again, C is going to be greater than 0 because our shift is to the right. We can also see that our midline here is in fact the x-axis. So that's going to tell us that there is no vertical shift. So when we put this together, again, using a cosine function, and we're going to name it g of theta, is going to equal 5, which is our A, cosine theta over 3 minus pi over 3. You could also write 5 cosine 1/3 theta minus pi. Any of these are correct.